In this video, we will look at how to graph a line without using a table of values. So when we're graphing a line, we do need our equation to be in y equals mx plus b. That way we can identify the slope and the y-intercept. So let's look at the steps while doing this first example. So step 1 is to identify the slope and y-intercept. So y equals 2 over 3x minus 5. The number in front of the x is always the slope. So in this case, 2 over 3. And the y-intercept is always the constant, which in this case is negative 5. From here, now that we've identified everything, let's go ahead and plot the y-intercept, because right away, that's a coordinate that we know on our line. So the y-axis is the vertical. So I go down to negative 5, and there we are. Now we're going to use our slope. We know that the top is your rise and the bottom is your run. Both of these numbers are positive, so we're just going to rise 2, so go up 2, and then run to the right 3. 1, 2, 3. And after I apply my rise and run, I plot my new point. And then I can repeat this. I can rise another 2 and run another 3, and there's another point. And then I can connect my dots. If I really wanted to get a point to the left of the y-axis, I can repeat this rise and run, but in opposite directions. So instead of going up 2, I can go down 2. Instead of going to the right 3, I can go to the left 3. And then I can also get a point to the left before I connect the dots, if I wanted to. But really, you only need 2 points to create a line. And now we will connect with a ruler and put arrows at the ends. And because I only have one line on this graph, I don't need to label it with the equation. And you can do a logic check. I see my slope is positive. I want my line to be going upwards, and it is. Okay, let's try the next one. In our next one, we have y equals 3x minus 7. My slope is 3, which I'm going to write as 3 over 1. That way I can see the rise and run clearly. And my y-intercept is negative 7. So I'll start off by plotting the y-intercept on the y-axis. Make sure you don't accidentally plot this on your x-axis. And now I'm rising 3, running 1. So 1, 2, 3 up, and 1 to the right. So here's my next point. And then I can do it again. 1, 2, 3 up, 1 to the right. I can do this as many times as I want, but at this point, I can just connect the dots. And again, don't forget arrows at the ends because this line will go on forever. All right. In the next one, we have a negative slope. So right away, I do expect my line to go downwards. And if it doesn't, I know I will have messed up if it doesn't. So my slope is negative 3 over 5. If there's a negative, choose a spot for the negative, either at the top or at the bottom. Here it's already on top, so that's perfect. And our y-intercept is 4. Like always, plot the y-intercept on the y-axis. And now for our rise. The rise is negative 3, which means I'm actually going to go down 3, and then my run is positive 5. That negative does not affect the denominator if I did not put it there. So I'm still going to go to the right. If the denominator had been negative, then I'd go to the left. And I can swap where I put the negative if I wanted to. And I'll show that to you in a second. So let's rise negative 3. So down 3, 1, 2, 3. And then run positive 5. So 1, 2, 3, 4, 5. And looking at where I plot this point, if I were to connect the dots, the line would be going downward, so that's perfect. Now, I could have also taken this slope, if I wanted to, and put the 5 with the negative. So then I would be rising positive 3 and running negative 5. So if that were the case, I would go rise 3, so up for positive, and because my run is negative, then I would go to the left. 1, 2, 3, 4, 5. And see how it matches the rest of my points? This is still good. So now we connect our dots, put an arrow, the line's going down, so I'm happy. So main thing here, make sure you do plot the y-intercept on the y-axis, okay, and not on the x-axis, and be careful with your signs. So positive means up for rise, to the right for run. Negative means down for rise, left for run. Okay. So in the next two, we have a little problem in that these equations are not in y equals mx plus b. But that's not a problem because we know how to convert our equations into y equals mx plus b form. So just a reminder, we can circle what we're isolating for and then bring everything else to the other side. So that means we're going to have y equals the 2x turns negative and the 7 turns negative. So at this point, I want you to pause the video, identify your slope and your y-intercept and try to graph this, and then come back to check your work. So your slope is -2, which I'm going to write as -2/1, and your y-intercept is -7. So the -7 I will plot right away on the y-axis in the negative region. Now, I need to rise -2 and run 1. Notice I chose to put my negative on top. So if I'm going to go down 2, that means 1, 2, and then to the right 1. Now, I only fit 1 point. Maybe I want to put more for a little bit of accuracy. So I'm also going to write my slope the other way, which is +2 over -1, which would tell me I need to rise 2 and then run -1, which means to the left. So there I am. And I can repeat up 2, left 1, up 2, left 1, however many times I want before I connect the dots and put my arrows at the ends. So check how you graphed it. If you did it well, that's great. If you made a mistake, see where your mistake was so that you don't make it in the future. All right, the next one we have to rearrange again, but a little more to it. So I'm going to circle my -4y and bring 3x to the other side. So -4y equals -3x because it moves over the equal sign, but the 8 hasn't moved, so I'm not changing its sign. And then I'll divide everything by -4. And that gives me y equals, okay, so I have -3 over -4. The double negative turns positive, and the fraction can't be reduced, so just 3 over 4, x. And then 8 divided by -4 is -2, meaning our slope is 3/4, and our y-intercept is -2. So again, I want you to pause here, plot your points, come back to see if you were on the right track. So our y-intercept is -2, so here it is. And then I want to rise 3, 1, 2, 3, and run 4. And both of them are positive, so I'm going in the positive direction each time. 1, 2, 3, up, 1, 2, 3, 4 to the right. And if I wanted to practice going in the other direction, I could go instead of up, down, instead of right, left. And you'll know if you've done it correctly if the point is in the same direction and it follows the line, which it does. So that's what we should have there. All right, the final graphing is some special lines. So if we look at our first set, we have y equals 8, y equals -3. So I still have that y equals format, but I am missing that x term. So really, if I wanted to, y equals 8, if I wanted to throw that x term in there so it looked like y equals mx plus b, I would have to write 0x plus 8 because 0 times anything is 0, so it's technically not there. But when I write it like that, well, now I see that my slope is 0 and my y-intercept is 8. So I go ahead and I'll plot that y-intercept. Now for my slope, 0 or 0/1, I'm not rising. I'm rising 0. All I'm doing is running to the right or to the left. It doesn't matter. So if I keep running to the right, right again, what you should notice is that I'm just creating a horizontal line. And because I am going to draw another line, I'm just going to label it y equals 8. And for the next one, again, I'm missing that x term. So the slope must be 0, and the y-intercept is -3. So I'll plot my -3, and once again, I'm going to rise 0, and I'm just going to run 1. So I'm rising 0, then I go to the right one, and again, and again. I can also go to the left, because I know I'm going to continue this line. So once again, a horizontal line. So just to summarize this horizontal line, horizontal lines have a slope of 0 always, and their equation is always in the form y equals a number. You're missing that x term because the x term is what attaches the slope, but our slope is 0. All right, let's try the next two. The next two are x equal -2, x equals 5. This isn't even in y equals mx plus b, so I'll make a note. What this means is if it's not in y equals mx plus b, we probably don't have a slope. The slope is undefined. And instead, it's just telling me x is -2. So x is always -2. So maybe I'll start on the x-axis. Where else is x equal to -2? Well, right above, 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 or below. This is a vertical line. You can also think of that undefined slope, if we remember, as 1/0, because we're not allowed to divide by 0, which is showing you that I'm going to rise, but I'm never going to run to the right or left, which shows that vertical line. And then if I'm doing x equals 5, actually let me label this first. I'll start on the x-axis at 5 because they're telling me x is equal to 5, and then again, I'm going to rise, but I'm not going to run. And I can also go in the negative direction. And here we are. So vertical lines have an undefined slope, and the equation is always x equals a number. And another reason is because if you look at the vertical line, any point on a vertical line has the same x coordinate. -2, 0, -2, 4, -2, -2. Same thing here. This is 5, 2, 5, 5, 5, 0. The 5s always match the x coordinate. And then if you look at the horizontal line, the y's are always the same. So 0, 8, 2, 8, 5, 8. Or this next one, -2, -3, 1, -3, 4, -3. It's the y coordinate that is constant. So that's another reason why these equations don't follow that y equals mx plus b so perfectly. Their slopes are different, like 0 or undefined, but also the equation is telling you what the x or y coordinate always is. And that's it for graphing. So for your typical y equals mx plus b form equations, identify your slope, identify your y-intercept, start off by plotting the y-intercept, and then apply that rise and run. For horizontal and vertical lines, they're super quick to graph. You just have to be able to identify them.